So I want to welcome you for this class. Today we said we would be introducing ourselves to a new topic, and the new topic is actually called linear algebra. Linear algebra. And calculus. Linear algebra and calculus. That is the topic for today. We have looked at a number of different topics, both online and physical. Guys, just a minute. Seems I'm not getting power. So just like you see the word linear algebra and calculus, we are going to divide this into two. The part that deals with the linear algebra, and of course, under the linear algebra, we shall be looking at the equation of a straight line. We have been seeing it in one way or the other when we're looking at regression analysis. Under time series, we have seen the same. At one point, we would say that this respects an equation of a straight line, etc., etc. So under this topic, we shall be in a position to know what actually a linear, a line, a straight line means, and how it looks like. We're supposed to determine how it looks like. So we shall be required to look at that line, the simultaneous equations, or what we normally call a system of equations. We shall also look at graphs and functions. There is what we call polynomials. Any equation whose upper degree is greater than a 2 is a polynomial. Shall look at quadratic equations, the revenue functions, cost and profit, depreciation, and its application. When I talk of the applications, that is when we shall be looking at the turning points, which can be maximum or minimum point, the profit function, etc., etc. So this topic is not hard, and it is preferred so much by the examiners. For those of you I study with financial accounting, the same way I normally tell you that errors and suspense accounts don't miss in any paper, is exactly the same way I will tell you that this will not miss as well. So linear algebra and calculus will always be there. And there are two different questions that are normally set. One, that part to do with the equation, solving an equation of a line. And two, that part that requires to calculate questions from calculus, its application. So we should be ready to find the different parts of this topic. So starting with linear algebra, the key parts that we are supposed to look at are the functions and graphs. So we would be asking ourselves, what is a function? Anyone who can have an understanding of a function, how would you define a function? Without wasting time, I would say that a function, normally we use it for purposes of describing mathematical relationship between two or more variables. So a function helps us to determine a relationship. If, for example, describes mathematical relationships, describe mathematical relationships between two or variables. So with a function, you would expect that you have a relationship, and this relationship has been expressed quantitatively to bring out a relationship. It is not so very different from an equation, which we say an equation is a function that specifies an exact relationship between two or more variables. So if you have an equation of, say, y is equal to x squared, that simply means that functions have a relationship that if we have a change in x, that would ideally affect our y. So y depends on x. And in this case, we have a relationship. If you had y is equal to x plus 4, this is a function as well. A change in x would affect a change in y, or the value of y. So depending on what we have in form of an equation, we shall always see a relationship. So amongst the different equations that we look at, we have said an equation is a function that specifies an exact relationship between two or more variables. So amongst the different equations, we can find a simultaneous equation. Now, simultaneous equations normally involve two or more quantities which are related using two or more equations. So you're going to find that you have a number of different equations, and these equations have two or more quantities. When I talk of two or more quantities, the equation has three different unknowns. The equation has two different unknowns. So when we say that a simultaneous equation is an equation that involves two or more quantities, we are referring to that. And so we would expect that this has a number of different equations. They could be 2 or 3. So we actually call it a system of equations. So simultaneous equations are part of the different functions or equations that we shall find, or we shall look at to determine the different unknowns. So we are going to be provided with a system equations. We can have a system of 2, a system of 3 at this level, which can be solved. So to solve simultaneous equations, there is always a need to find the values of the variables which are actually included within the equations. So if I have a system of equations, if I've been provided with a system of equations and we have x plus y equal to 8, and then x plus 3y is equal to 15. That is already a system of equations. But within this system, we have different quantities or variables, which are x and y. So we have got to determine the different quantities or variables within that system of equations. So the system of equations or simultaneous equations can be classified as simultaneous linear equations. We are going to look at simultaneous linear equations. 2, we have simultaneous linear equations. 3, we have system of bilinear equations. Equations. And 4, we have simultaneous polynomial equations. And 5, we have system of differential equations. So we shall look at this level. We are going to look at part of this and part of those, including these ones. It is this nonlinear that we don't look at. But in one way or the other, when I look at polynomials, then I'll be looking at the systems of nonlinear equations. As long as it is not a line, it is a curve, then we can say that it is nonlinear. When I look at a system of bilinear equations, it simply means I'm looking at a system of 2 equations. When I look at a system of linear equations or system of linear equations, then I'll be looking at either again a 2 or 3 system of equations. When I look at the simultaneous polynomial equations, then we shall be looking at equations whose upper degree is more than a 2. And then we have those bilinear sometimes we are actually looking at those whose degrees is a 2 and it is a quadratic. So at the same time, we are going to look at solving quadratic equations. Quadratic equation, but you're going to look at each of these. And then systems of differential equations under calculus, we shall be looking at those equations. So I've discussed about the different systems, and generally, when we have been provided with a 2 by 2 system of equations, it has got, this is a 2 for a 2 by 2 system of equations. System of equations, we can have it in the form of ax plus bx, by equal to c. Equal to d. So we have ax plus by equal to c, and this is equation 1, then this is equation 2. So that is a system of 2 equations. But at the same time, we can have for a system of a 3 by 3. System of equations where you can have 3 different unknowns, ax plus by plus cz is equal to b, ex plus f5 plus gz is equal to h, and jx plus ky plus lz is equal to m. That is a system of 3 by 3. But you expect that in the first position, you have x, in the second position, you have y, and third position, you have z. Similarly, up here, x and y. So they will always be formed in that same order. They will always be formed in that same order. So simultaneous equations can be solved using various methods. Now we are going to look at how do we solve these? What methods are available to ensure that we solve these different simultaneous equations, both a 2 by 2 and a 3 by 3. We have 1, elimination method. We have 2, substitution method. 3, graphical method. And 4, matrix method. So we are going to solve these using those 4 methods. And they are saying that methods to solve simultaneous equations. One, elimination. Some two, we have substitution method. 3, we have broken method. And 4, we have matrix. We have matrix. So let's look at the first one as elimination method. So like I said, in this method, we've got to add or subtract the equations to get the equation in one variable. We need to add or subtract equations to get one other equation that is going to be in one variable. So if the coefficient of one of the variables are the same, the signs and the signs of the coefficients are opposite, we can add them. Should you find that you have 2x plus 4y is equal to 6, and then you also have 2x plus 6y is equal to 20. In this case, it simply means because these two variables are the same, x, and you want to eliminate x, say, for example, I'm going to subtract the two equations. Had I found that this was a -2, it means I'll simply add this to ensure that I simply get a 0. So I want to eliminate one of the variables, and eliminating one of the variables would actually enable me obtain the other. Remember, when I say solve the system of equations, it means get the value of x and y. Get the value of x and y. For example, example 1. Under elimination, we have been required to solve the system of equations of 2x plus 7y equaling to 10 and 3x plus y equaling to 6 by elimination method. So those are the two equations. We will write them and subtract x plus 7y equal 10. 3x plus y is 6. We have 1 and 2. So which of those two variables can I eliminate? I am asking, which variable should we eliminate first? What do you think? Should it be x or
x?
We eliminate x. You can choose any of the two. You can choose to eliminate x first, or you can choose to eliminate y. And whatever you have chosen, it is very possible, and you can always get the answers right. Now, if someone says that I eliminate x, if someone says I eliminate x, I'm going to look at the coefficients. Do we understand a coefficient of a variable? If I have 2x, the 2 is a coefficient. If I have to eliminate x, the first thing to do is to look at the coefficients of x in both equations. So in the first one, what is the coefficient of x?
Is 2.
And in the second one, what's the coefficient of x?
Is 3.
It is 3. So if we have 2 and 3, and we are interested in eliminating x, it means I must ensure that the coefficient of x is actually the same. I'm going to ensure that the coefficient of x is actually the same. So what I'm going to do, I'll put a line like this. I say times the coefficient of x in equation 2, and this one times the coefficient of x in equation number 1. I'm picking this 3 to multiply it in equation 1, and picking this 2 to multiply in this. Now, when I multiply 3 times 2, that gives me 6x. 3 times 7, that is plus 21y. 3 times 10, which gives us a 30. as I multiply that coefficient, I do it to the entire parts of the equation. The entire parts of the equation. The same happens to the second one. 2 times this, it gives us 6x. 2 times y plus 2y, 2 times 6, which is 12. And that turns out to be equation 3. And then this is equation 4. Equation number 4. So when you check equation 3 and 4, they have x sharing a coefficient. To eliminate it by subtracting. Because when I subtract 6x from 6x, I would ideally get a 0. So what I'm going to do, I'll just draw a line here. 6 minus 6, I'm subtracting 6 minus 6, I get a 0, plus 21x minus 2y, this gives me 19y. 30 minus 12, this gives me a 18. That gives me a 18. So in one way or the other, I have 19y is equal to 18 divided by 19 divided by 19. When you have this, y actually equal to 18 over 19. 18 over 19. I was interested in getting the values of x and y. Having obtained the value of y, then I can get back and choose any of the previous equations to solve for the value of x. Looking at the initial ones, these are 2, this and this. I can take any to substitute for y so that I can obtain x. So if 3x plus y equals 6. Then substitute y equal to 18 over 19. So I have x plus out of 19 being equal to 6. Being equal to 6. So can we solve for x? In that case, we have 3x equal to 6 minus 18 over 19. This is over 1. So that simply means the rate is equal to 19. The LCM in this case is a 19. That is the lowest common factor. Therefore, I'll be having 19. 19 divided by 1, which is 19. 19 times 6. That is 1, 1, 4 minus 19 divided by 19. It is 19. It is 1. 1 was 18 minus 18. So that gives you 114 minus 18 over 19. Over 19. So that is 96 over 19. So we have 3x being equal to 96 over 19. So I'd be like times 3 on either side. Are we multiplying or we are dividing? We are not multiplying. This we divide by 3, divide by 3 is 3. So how 19 times 3, that is a 57. So x is equal to 96 out of 57. 96 divided by 57, which is 32 out of 19. So our x is equal to 32 out of 19. And that is our value of x. So our x is equal to 32 out of 19, whereas our y is equal to 18 over 19. So we have solved the value of x and y, and therefore we have solved a system of equations using elimination.
Excuse me, sir.
Yes.
Can I convert them to decimal places?
It is okay. However, in
Okay.
decimal places, you won't get the final answer as exact as it is here with our denominators, but it is okay. You can always get your decimal points.
Excuse me, sir.
Yes.
I converted mine, and the answer is the same
You converted yours?
into decimal. I got the same answer.
I don't think what you have is exact as this. What is the value of x that you have?
It is 1.68.
1.68. So when you have
Yes.
32 out of 19, you get 1.68421052.6. It is not exact, but it is approximately that. And your answer will be right. You get what I'm saying? Because when I have 32 divided by 19, that gives me 1.68421052.6. But from your conversion, for you, your final answer is 1.68, which is very okay. Approximately, that is a right answer. I hope we are very clear with the elimination.
Excuse me, sir.
Yes.
I'm asking about the step where we divided the 96 divided by 19, then divided by 1/3. That, yes, I could not understand that very well.
This one here. I have
3x, the upper one.
is equal to 6 minus 18 over 19. That step. Yes.
No, that 3x plus 18 divided by 19.
You don't know where
The upper
we
step,
came,
yes.
we don't know how we came to this.
Yes.
Okay. We are saying that having eliminated x and we determined our y, we say that substitute y in any of these two. You can choose this or you can choose that.
Yes.
Are you together? Now, for us, we have chosen the second one. We have chosen the second one. So where there is y here, I'm putting the value of y, which is 18 over 19, to solve for x.
Yes. Yes.
So, and that is how, because here it is 3x plus y, but y is 18 over 19. So that's why I'm putting 18 over 19, which is equal to 6. Are you getting it now?
Yes, I can
Yes
pick
or
it.
no? So it
yes,
is this.
until.
Sorry?
It's okay. I can pick it now.
You're picking it. So ideally, we have simply substituted in the second equation the value of y to determine the value of x. The other person could pick equation 1 and you would still get the same answer. You still get the same answer. So our answers are those. Let's do another one very fast and see how we can get it. We have 12x. We have 12 questions. We have 12x minus y is equal to 3. We also have 5x minus 10 is equal to 2y. Now, when you find such an equation, first of all, you're going to first organize it such that the second equation appears in the same way as find the first equation. So this is example. So if my first equation is in the form of 12x is equal to 3, then the second equation, I can also rearrange it by saying that this is going to be 5x. Then this 2y, because it is the equal sign, once cross the equal sign and comes this other side, to become a minus as 2y being 2. This 10 will move to the other side, the side that I have constants. Remember, we said an equation is in the form of ax plus by equal to c and ax plus fy equal to h. So it must be in that format. Therefore, I'm going to make sure that this moves this other side and then this moves this other side. That is what I'm going to do. So I have 5x minus 2y is equal to 10. Is equal to 10. I have rearranged these equations in this format. I have rearranged the two equations in that format. Therefore, from there, I can decide to eliminate. Since we eliminated the x in the first place, let's try eliminating y in this case. And when I look at the coefficients of y, in the first equation, the coefficient of y is a -1, and in the second equation, the coefficient of x is a -2. So, this is what I'm going to do. I can say -1, -2. I said we draw a line there. Because we're eliminating y, I'll get the coefficient of y in the second equation, and I multiply it there. And I get the coefficient of in the first equation, and I multiply it there. So this gives me -2 times 12, that is -24. X negative times -1 plus 2y. Negative times 3 is equal to -6. -1 times 5, that's -5x. -1 times -2x, that is plus 2y. -1 times this, which is -10. So y in the first equation and the second equation, the two have the same coefficient. And because they have the same coefficient, then we are going to ensure that we eliminate y by subtracting. When you have -12 minus 5, -24 minus -5, that gives you a -19. Because this is going to be -24 minus -5. And a negative times a negative, they become a positive, which gives us -19. So -19 is that, and therefore, when I sub 2 minus 2, this will give me 0. This is equal to -6 minus 10. This becomes a positive, and therefore, this is going to give me a 4 positive. This is equal to 4. That is equal to 4. This is minus 19x. So ideally, we have x minus 19 is equal to 4 divided by minus 19 divided by minus 19. Our x turns out to be minus 4 out of 19. This minus, whether it is below or up, it is the same, because once you divide this, it will go with its negative. So that is why I'm giving you my x as that. Those of you who have or who want to work in decimal points, at that point you can convert to decimal points. And you have your value of x less than 1. So which of these two can we pick? Should it be 1 or 2? Can we pick 1? So taking equation 1, substitute the value of x. Substitute the value of x. Then that is 12x minus y equal to 3. But x is equal to minus 4 out of 24. Minus 4 out of 19, sorry. So I'll have 12 times minus 4 out of 19 minus 5 is equal to 3. This is 12 times 4. This is 48. Minus over 19 minus 5 equal to 3. Minus y equal to 3. So this y will move the other side, and the x will move this other side to correct like terms together. So I'll have minus 48 over 19 minus 3. It is equal to y. It is equal to y. So minus 48 over 19 minus 3. That gives us minus
45
over 19 equal to y. Equal to y. Or your y is equal to negative 5.53. It is you to determine. So that is how you would go ahead and solve using linear elimination method. Method number 2, we have substitution method. We have substitution method. So with this method, we shall actually make one of the different variables. We are supposed to make it a subject and then substitute it in the other. So given two equations, we can always do that. We can always do that. We get one of the equations, we make the variable the subject, and then substitute in the other without necessarily eliminating. For example, we can be given an equation of this kind. Use substitution method to solve for x and y. Example 1. We have x plus y is equal to 4. And 2x minus 3y is equal to 9. So if that is the case, we can say make the subject. Make x the subject. And if we are making x the subject, means x is equal, sorry, make x subject in equation 1. But also another person could start with equation 2. So depending, you can just have to follow through. So I'll be like x is equal 4, because previously y was plus, then we see minus 4. It is 4 minus y. 4 minus y. So can go with equation number 3. Substitute in the remaining equation. So in this case, when we use equation 1 to get the object, we'll leave behind. So the one which is remaining, that is where we're going to substitute the value of x. That will be the point where we substitute our value x. So substitute 3 in 2, but 2 has given us x minus y is equal to 9. Where there is x, I'm going to substitute the value of x. So I have to, don't forget to open brackets, because x here has various numbers. X is 4 minus y minus 3y equal to 9. So I have eliminated my x already through substitution. I have eliminated my x already through substitution. Can I open the brackets? I have 2 times 4, which is 8, 2 times minus y, minus 2y, minus 3y being equal to 9. This is 5y is equal to 9. Therefore, minus 5y is equal to 9 minus 8. 9 minus 8. So our minus 5y is equal to 1 divided by minus 5 divided by minus 5. Y is either a 1, a negative 1 out of 5, or negative 0.2. Negative 0.2. Because we know 1 divided by 5, we actually get 0.2. I request that we mute, because sometimes you only unmute when you want to ask a question, but there is some noise which comes through that is disrupting. So that is how we solve simultaneous equations using substitution. Using a substitution method. Now, if the examiner does not specify which method to use, you can use any of them, apart from when he has specified and he says use substitution method, use elimination method. There you have no option. You won't have any option. You won't have any option. Example 2 under this.
Excuse me, sir.
Yes.
After getting the value of y, you don't go back and even substitute it in any of the equations to get the value of x.
Don't you already have x?
No, x we got it, but we don't have the
We
actual.
stopped it somewhere. We already had, remember we are supposed to have our values of x and y. So you are supposed to have a y as well. So we have to substitute this y in this equation number 3 to determine the value of x. Thank you. So you have x minus x is equal to 4 minus y. And we already know our y. So it means your x is equal to 4 minus 0.2. 4 minus 0.2. So this becomes plus, and therefore x is equal to 4.2. 4.2. And if we don't use 4.2, then we can actually express it in form of fraction. Our x is equal to 1 out of 5. And 1 out of 5. Thank you.
Okay.
So in our book, in the reader, we have some equations, trial questions. We have some equations which says, example 2, I'll pick x minus y is equal to 0. And 4x plus 6y is equal to 40. This is 1 and this is 2. We can go ahead and solve those. Starting with the first one, 1 x minus y is equal to 0. Therefore, x is equal to y. X is equal to y. We can substitute in any of the other. Where there is x, I can put y. Where there is y, I can put x. So this would be equation number 3. So if that is equation number 3, I'll have to say substitute x in 2. And remember, our 2 is 4x plus y is equal to 4. So x is equal to y, meaning that it is a 4y plus 6y is equal to 40. This is 10. Y is equal to 40. Divided by 10, divided by 10. Y equal to 10. And because we said, since x is equal to y, then x is also equal to 10.
No, our y is equals to 4, not 10.
Oh, it is equal to 4.
Yes.
What is happening to me? Am I telling? Because we divided this, our y is equal to 4. And this x is equal to y, then this is 4. So when you have x minus y, you would actually get a 0. Now that is the second method. And the third method is when we are looking at the matrix method. Matrix method. Now the matrix method involves expressing the equation in a given format. We all know how a matrix looks like. We all know how a matrix looks like. So a matrix is going to come in. So this one involves expressing the equation in format of A, B, C, and D, into xy being equal to EF. So it involves expressing an equation in that format. It involves expressing an equation in that format. Now, with this method, we have what we call a matrix of the coefficients of x and y. We have matrix A, which is a matrix of coefficients of x and y. And then EF, these are the coefficients of x and y. And then these are the constants. Those are the constants. So normally say this is matrix A. These are the variables. And these are the constants. So matrix A is saying that this is a matrix of coefficients. Of x and y. Of x and y. So ideally, that is how we are supposed to have it. That is how we are supposed to have it. So matrix A equals to that. It is equal to that. So in order to find the values of x and y, we shall always be required to find an inverse of the matrix A, which must be determined and then multiplied on both sides to make x and y the subject of the equation. Now, we are saying in order to find the values of x and y, it is important that we find an inverse of this matrix, matrix A, which is multiplied on both sides to determine the value of x and y. So the inverse of matrix A, inverse of matrix A. You will note that I'm writing it that way. Inverse of matrix A is obtained by, determined by inverse of matrix A is determined by inverse of matrix A is determined by inverse of A is equal to 1 over the determinant times the adjoint of A. So we need to understand how do we determine, or what do we mean by a determinant? How do we get a determinant? And again, what do we mean by adjoint? And how do we get the adjoint? How do we get the adjoint? That is the inverse of a given matrix. Let me ask a question. What is the inverse of 2?
Is
Who knows
1 over 2.
The inverse of 2 is 1 over 2. So when you get a matrix times its inverse, that gives you a 1 always. So when I get this times this will give me a 1. When I have matrix A times its inverse, which is times 1 out of A. Now 1 out of A can also be written as A to the power -1. That is why C of A is written as A times A -1. It can also be written, sorry. We have 1 out of 2. This is the same as 2 to the power -1. So when I get an inverse of 4 is going to be inverse of 4. It shall be 4 times 1 out of 4, which gives me a 1. Always, as long as you get a value, you multiply it with its inverse, you must get a 1. So when I have a matrix and I determine the inverse of that matrix, and that matrix is multiplied with the inverse, then I'm very sure that I'll be getting a 1. I'll be getting a 1. So if that is the case, all this is not required, I'm going to remove it. I just wanted to show you how to get an inverse of a given variable. So someone is asking a question. Inverse of matrix A is given by 1 over determinant times the adjoint. So we'll be asking, what is a determinant? Determinant, or how do you get a determinant of a matrix? We say the determinant of a matrix is the difference between the product of the leading diagonal entries and the secondary diagonal entries. This is the difference of the product of the leading diagonal entries and the secondary diagonal entries. In other words, for a matrix of A, B, C, and D, A and D are entries on the leading and then B and C are entries on the secondary diagonal. B and C are entries on the secondary diagonal. Therefore, for me to obtain a determinant, if this is a determinant of A, it is equal to the difference of the product of A, that is the leading diagonal, minus the product of the secondary or minor diagonal. Now the leading diagonal can also be called major diagonal, and this is minor diagonal. Can we mute, guys? I'm hearing someone who is with us. Please, your microphone mute. So our determinant, in this case, it is given as this. That is how we get a determinant. And we need to know, how do we get an adjoint? How do we get an adjoint? The adjoint of a matrix. The adjoint of a matrix. The adjoint of a matrix. So the adjoint of a matrix, this is obtained by interchanging positions. Interchanging positions for the leading diagonal, bracket major, and multiplying the secondary stroke minor diagonal with the -1. With -1. So what do I mean? If I have matrix A, which is equal to AB, CD, the adjoint of A is equal to DA by interchanging the position of the entries of the leading diagonal and multiplying -1 in the minor diagonal. That is the adjoint. That is our adjoint. That is our adjoint. Hence, the inverse of matrix which is equal to 1 out of determinant det of A times adjoint will be we shall have our inverse as equal to 1 out of AD minus BC times D negative C negative B and A. That is our inverse of a matrix. That is an inverse of a matrix. So that inverse has got to be multiplied on both sides to ensure that we obtain values of X and Y. Ensure that we obtain the values of X and Y. So let's look at an example. The example we have used matrix method to solve the simultaneous equations. We have 3x minus 900 equal to minus 5y minus 1400 plus 10y is equal to negative 4x. So let's rearrange this in the format of a matrix or in the format of an equation. Rearranging the equations. That gives us x plus 5y. This is next. Once the equal sign becomes a positive, and this is equal to this negative. Once it crosses the equal sign and it goes this side, it becomes a positive. In the second one, again, this is a negative. Once it crosses this equal sign, it becomes a positive. So I'll have 4x. This is plus 10y being equal to 1400. So I have the constants, I have the matrix themselves. So let's formulate. The next step is to formulate the matrix equation. So we have from here 3, 4, 5, 10. We have 3, 4, 5, 10 into xy equal to 900, 100. 1,400. 1,400. So we now determine the determinant and adjoint as our inverse. As our inverse. As our inverse. We know that our inverse. Remember, we said for us to get the values of x and y, we multiply the inverse on either sides, on both sides. For you to get the values of x, y, go ahead and multiply on both sides the inverse. And we are saying that our inverse is equal to 1 out of determinant of a matrix. I would say A, assuming this is my A, and this is B, this is my C. So I'm getting the determinant of matrix A times the adjoint. So can we get the determinant? Determinant of A. We see determinant of A, we get it by interchanging the positions. No, the determinant is obtained by getting the difference between the product of the major diagonal and the product of the minor diagonal. So the major diagonal, we say it is this. That is the major of leading. And the minor diagonal is This is minor. Or secondary diagonal. So our determinant of 3, 4, 5, 10 is equal to 3 times 10 minus 4 times 5. Give us minus 10, which is 10. That is our determinant. So our determinant is that. So we need to get our adjoint. And we said with the adjoint of 3, 4, 5, 10. We interchange the positions of the entries of the major diagonal, and we multiply -1 by the entries of the minor diagonal. 2, 10, -4, -5, and 3. That is my adjoint. I have interchanged the position of the major diagonal. Here, interchange. And then I have multiplied the entry of the minor diagonal by -1. Here, times -1. This one, interchange. Interchange. So the inverse of A is equal to 1 out of determinant, which determinant is a 10. I'm now substituting in this. 1 out of 10, because my determinant was a 10, times 10, this adjoint, -4, -5, 3. That is my inverse. So I'm going to put this inverse, this determinant inside this. I'm going to open brackets. And once you open brackets, it will work with each. So we shall have our inverse of A being equal to 10 times 1 out of 10, 5 times 1 out of 10, -4 times 1 out of 10, 3 times 1 out of 10. I'm opening this, I'm taking it inside. This 1 out of 10 multiplies in each of these. It multiplies or sorry? What did you say? Was she talking to us? Okay. It seems she wasn't talking to us. So get this determinant and multiply it with the values or the entries within the adjoint. This determinant is multiplied together with the adjoint. And by so doing, you open up brackets. Say 1 out of 10 times 10, 1 out of 10 times -5, 1 out of 10 times -4, 1 out of 10 times 3. And that gives us, what is 10 out of 10? So our inverse will equal to, by looking at this, 10 times this, it is give us a 1. We have -0.5. Then we have negative 4, 0.4, and 0.3. I'm getting this, just solving this. This with this. This negative 0.4, negative 0.5, negative. And then this one is out of 10, which is 0.3. That is why I have it as this. This is my inverse. We have said that once we have that, the inverse is multiplied on both sides on the original matrix. Remember? Original matrix is 3, 5, 3, 4. 5, 10. Into xy being equal to 900 and that is the original matrix. So we are saying that having obtained our inverse, we multiply it on both sides. So I will have 1 the inverse, negative 0.4, negative 0.5, and 0.3. This side, and then this side is the same thing. 1, negative 0.5, negative 0.4, 0.3. But remember, when you have a matrix of A times the inverse of A, that gives you a 1, meaning that A times A power negative 1, this should give us a 1. So where you have this is the inverse, this is the matrix, so you have a 1. Are we together on that step? Where you have this,
Yes.
this is the inverse times matrix, because we know we have a matrix times its inverse gives us a 1. Therefore, this times this times this, it gives us a 1. And that leaves us with x and y alone, which is equal to 900 out of 1,400 into 1, negative 0.5, negative 0.4, and 0.3. That is the next step. And from there, we use row by column to determine our x and y. So we shall come and say xy will equal to, we are going to determine row by column. So row by column, row by column. Do you see that? Another person would have written it with the 900 here, 900 and 1,400, such that you don't have this. It is a better tool. You have row by column, row by column. So to get this, I'll be getting 1 times 900 1 times 900 plus minus 0.5 times 1,400. That is the row. This is the row, and this is the column. So 1 times this times this. And again, I have row by column, this negative 0.4 times 900 plus 0.3 times 1,400. 1,400. So that gives us, can you obtain the values that you have on top are the X and below are the Y. So 1 times 900 plus open brackets negative 0.5 times 1,400 close brackets, and that gives you 200. Then here you have negative 0.4 times 900 plus 0.3 times 1,400, which is 60. So our X is equal to 200 and our Y is equal to 60. That is how we use the matrix method to solve. That is how we use the matrix method to solve our simultaneous equation. And this is common because they know it involves obtaining a determinant and an adjoint. So you should know how to deal with the determinant and an adjoint.
Excuse me, sir.
Yes.
About on the step of remember the original matrix. I wanted to know how this cancels out with the original, because we remained with xy is equal to how this first, the one we generated, cancels out with the original. It's just
now,
automatic.
Okay, I would say it is automatic, but it gives you what we call an identity matrix. An identity matrix, which means 1, is always, it always comes in this format of 1, 0, 0, 1. So once you try to multiply this, it gives you what we call an identity matrix. And identity matrix means a 1.
Okay.
So I didn't want us to go into that because I ultimately would get a 1. Are you getting that?
Okay.
Good.
Thank you, sir. Yes, sir. Thank you so much.
So that is how you deal with simultaneous equations using matrix method of a system of a 2 by 2. So lastly is the graphical method. The graphical method. Now with the graphical method, of course, we shall have 2 different equations, and then we shall need to determine points. Which points are supposed to be plotted on a certain graph. So always, where you have 2 equations, the easiest points to use is when we assume x to be a 0 and y to be a 0. Determine 2 points, and the 2 points will actually give us our point of intersection or intersection, and then we plot where the point, where the two lines actually meet. That will be the value of x and y. We are going to plot the different two lines that we have, and then the two lines where they meet will actually give us our 2 points. For example, if we are given two equations of this kind, 3x plus 5y is equal to 30. 2x plus 2y equal to 16. Assuming that is the case, assuming that is the case, and we have been told to solve the two using graphical method. Solve using graphical method. We are saying that determine two points on each equation. A line and plot where they meet would give us x and y. Would give us x and y. So this is 1, this is 2. From equation 1, we can say, which is 3x plus 5y is 30. We say this is x, this is y. We are determining two coordinates on the equation of a line. Because the upper dig on this is a 1, it means that is a straight line. So I just have to obtain any 2 points, which I'm going to plot. So if I say, if x is a 0 here, I'm just assuming any values. If I say if x is equal to a 0, what is our y? If x is equal to 0, what is y? So I'll have 3x, 3 times 0 plus 5 equal to 30. This is y equal to 30. So y is equal to 6. So this will be 6. How about when it is y which is a 0? Because I need to get 2 points. I need to get 2 points. So if y is a 0, y equal to 0, then our x we don't know. So we shall have 3x plus 5 times 0 is equal to 30, which x is equal to 30 divided by 3 divided by 3. Our x is equal to 10. Our x is equal to 10. So this shall be 10. Remember, a coordinate is written in form the form of x, y. So in this case, x and y second. X is 0, so we have 2 coordinates, 0, 6, and 10, 0. You're going to find some people writing it as 0, 10, and 0. That is wrong. You have taken two values for a single variable. So it is 0 and 6, 10 and 0. That is a coordinate. So for the first equation, these are the coordinates that we are supposed to plot. Those are the coordinates that we are supposed to plot. Therefore, I'll move to the second one, which is x plus y is equal to 16. X plus y is equal to 16. So again, we are going to determine the values of x and y, two coordinates. So if x is equal to 0, then y will equal to, so come here and do this. This is x, this is y. When x is equal to 0, it is you have y is equal to 16 divided by 2, and y is equal to 8. Therefore, this is a 0, this is 8. Then you go ahead and say, how about y when y is a 0? If y is equal to 0, then x is equal to, we shall have 2x plus 0 is equal to 16 divided by 2 divided by 2. X is equal to 8. So we have 8 there. So our coordinates, we shall have 0, 8. Remember, this is x, y, and 8, 0, x, y, x, y. So we are going to plot those 2 points. Where the 2 meet, then we shall be in a position to obtain our x and y. Shall be in a position to obtain our x and y. So since the 2 are positive, we'll do this. Those of you who have papers, you would go on the paper. A graph of x against y. So this is y, this is x. So according to our points that we have, the biggest value of x is what? We have 10, and the biggest value of y is 8. So I'll come here and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, I've taken one small box to mean one unit on either axis. One small box to mean one unit on either axis. So I'm going to plot my points. This is 0, 6. Don't move any places on the x-axis, but move 6 places on the y-axis. So it is this. The second point, don't move 10 positions on the x-axis, but don't move any position on the y-axis. That is a line which I'm going to join. That is the line. line was, it had a name. The name is 3x plus y is equal to 30. Here, 3x 30. And I'll go ahead and plot the second one. X plus 2y equal to 16. 0, 8. Move 0 positions. Move 0 positions and 8 on y. 0, 8, which is here. And you have 8, 0. 8, 0, which is here. Again, we are going to join the two. I hope that's the right line. So that is where we are. So where these two are meeting, we have to try for me for it to go here because I've estimated. I don't know what you want purpose. That is my point. So my x is this, and my y is this. That is how we determine our x and y. Are we there? I want us to move to a system of 3 equations. System of 3 equations.
Excuse me, Mr. Frederick.
Yes.
Good evening.
Good evening. How are you?
I'm okay. Like for this graph, if they ask you to set the unwanted area for example, for this line 2x plus 2y equals to 16, which side do you set?
Okay. Now the unwanted area will come in when we are looking at linear programming. This is just determining the
Okay.
point of x
Thank you.
and y. The wanted and unwanted area, we are going to discuss when we get to linear programming. Is that okay?
Yes, sir. Thank you.
You're welcome. Okay, let's look at a system of 3 equations. So we have linear equations in 3 variables. Linear equations in 3 variables. Linear equations in 3 variables. So in most cases, there are situations where we are given linear equations in 3 variables, meaning that we are going to be given 3 different unknowns, A, B, C, all the 3 are not known. And if we have A, B, C not known, that simply means we are going to have a system of 3 equations. And that takes us back to the first page where we had our systems of equations, where we had a 2 by 2 and a 3 by 3. So using 2 of the equations, eliminate one of the variables to obtain an equation in the 2 variables. So majorly, the method that we shall be using here, or the methods that are going to be used here, are going to be combined. We are going to combine the elimination method, and at the same time, we shall combine it with the substitution method. Combine elimination method and the substitution method. Some say that using any 2 of the given equations, eliminate one of the variables to obtain equation in 2 variables. And again, using another pair of equations, eliminate the same variable, which will give a second equation in the 2. Solve the 2 by 2 system of equations in the normal way using the previous methods. So, if we are being provided with 3 different equations, and the equations have been given in a way that you have 3 different unknowns, in the first place, choose any 2 equations and eliminate one variable to remain with the 2 variables, and choose the other set of equations to eliminate the other variable, which is similar to the previous one that we eliminated, and then go ahead to solve the 2 equations that will be remaining. So this is what I'm saying. Example. Example. 3x minus y plus z. The question is solve the 3 by 3 equations is equal to 5. We have 2x plus 3z is equal to 4 minus 2y. We have x plus 3y minus z is equal to 11. Is equal to 11. Is equal to 11. So that is what we have to solve to obtain our x, y, and z. So we have 3 unknowns. So one, they are going to rearrange equation to select the first 2 equations and eliminate one unknown. Three, select the remaining equation and combine it with with one of the previously picked to eliminate a similar unknown. For solve the two equations formed. Solve the two equations formed. So for example, here, I'm going to rearrange this in the format of A plus B plus C. So this is 3x plus y plus z is 5. That is okay. I have interchanged things. This is minus y plus z. That is the first one. The second one, when you have 3x plus 2y, this y must move this other side to become plus, and then plus 3z is equal to 4. So I have x plus 2y plus 3z is equal to 4. Because I must have constants the other side alone, constants alone. And lastly, I have x plus 3y minus z is to 11. I have rearranged those equations, and therefore I'm going to solve them. I have rearranged those equations, and so I'm going to solve them. So we have said step number 1, rearrange. We have done so. Step number 2, select the first two equations and eliminate one unknown. So I'm going to select, if this is equation 1, equation 2, equation 3, I'm going to select the first two and eliminate one of the unknowns. So which one can I select? Which one will it? Sorry. We have 3x. Let me move to the next page. (3x) minus z plus minus y plus z is equal to 3. We have 2x plus 2y plus 3z. And lastly, x plus 3y minus z so call this one, this 2, and this 3. So selecting 1 and 2, eliminate variable x. Eliminate variable x. I have decided to eliminate x. So if I'm to eliminate x, it means I'm going to pick 3x minus y plus z is equal to 5. And 2x plus 2y plus z, 3z is equal to 4. Because we want to eliminate x, we said we look at the coefficients of x. So we set times 2, then times 3. We are doing this. These two multiplies this entirely, and even this one multiplies the other one entirely. This is equal to 2 times this, that gives us 6x. 2 times negative y, that is minus 2y. 2 times z plus 2z is equal to 2 times 5, which is 10. 3 times 2x, this gives us x. 3 times 2y plus 6y. 3 times 3z plus 9z. 3 times 4, this is equal to 12. We are eliminating x. Remember, we said selecting 1 and 2 eliminate variable x. So we are going to subtract the 2. This will give us a 0. Minus 2y minus 6y. This will give us minus 8y. 2z minus 9y. This will give us 9z, sorry. That will give us minus 7z. And 10 minus 12, that will give us minus 2. So our equation that we get here, it is negative 8y minus 7z is equal to minus 2. And this is equation 4. That is equation 4. That is equation 4. That is equation number 4. At the same point, we said from here, step number 4. Step number 3, select the remaining equation. So in this case, the remaining equation is, and pair it with any of the previously used. You can pair it with the first one or the second one. And then eliminate the same variable which we eliminated in the first place, which was x. So I'm going to select. So next, I'll be selecting one and 3. Eliminate x. Selecting 1 and 3, eliminate x. Selecting 1 and 3, eliminate x.
Excuse me, sir.
Yes.
I can't select 2 and 3.
You can, I said with any, as long as you're looking at the one which remaining and pick the of these. So you can pick it with this or this with that. Is that okay? It is very fine for you to take any, as long as you pick this one with any of these. With any of those, just pick any. So I have taken 1 and 3. So I will have 3x minus y plus z is equal to 5. And the other one is x plus dy minus z is equal to 4, is equal to 11. Is equal to 11. So we are eliminating x again. We are eliminating x. We are eliminating x. We eliminate x. Because previously we eliminated x. Even here we must eliminate x, such that the two equations that we remain with, they have similar variables. They have similar variables. So what you want to do is to do this times 1 times 3, because we're eliminating the coefficients of x. So this gives us, again, like what we did previously, x minus 5 plus z is equal to 5. And x plus 9y, it moves 3, 9y minus 3z is equal to 33. Is equal to 33. It out. So we subtract. This comes to a 0. Minus y minus 9y, it will give minus 10y. Z minus 3z is plus 5 minus 33. That will give us minus 29. 5 minus 33, that is minus 28. And this is equation number 5. Equation number 5. This is equation 5. So we can say solve equation 4 and 5 using any allowable method. At this point, you can use elimination, you can use substitution, you can use graphical, you can use matrix, because it has become a system of 2 equations. It has become a system of 2 equations. So you have the equations that you have is negative 8y minus 7z is equal to negative 2, and minus 10y plus 4z is equal to 28. Negative 28. So we are going to solve those two using any method allowed. So using any method. So for solving a 2x2 equation, you have negative 8y minus 7z is equal to minus 2. Minus 10y plus 4z is equal to minus 28. Minus 28. So which method should we use here? Which one do you prefer? Which is easy?
I think we use graphical method.
Use
Graphical
graphical is
method.
going to graphical is
Substitution
going to
method.
it's going to take time. You can't use graphical here. You can use substitution, one of those two.
Yes.
Let's use elimination again. It doesn't take a lot of time. That's my submission.
So if we use elimination, which variable should we eliminate first?
For me, I've eliminated y.
Why?
Okay. If we're eliminating y, we shall say that this is times minus 10, and even this one is times minus 8. So with this, it will give us minus 8y, 10 times this is the plus, because this is minus. minus 10 times 8, minus 8 plus 80. Then plus 70, which is equal to 20. This minus 80 plus 80, y minus 8 times 4. Is that 32? Minus 32, z being equal to 8 times 28 plus 2 to 4. 2 to 4. But because we want to know why we subtract, it means this will be 0. 70 minus 32, that is 70 plus 32, which is plus 102 z, which is equal to, when you get 20 minus 224, that gives you negative 204. Hence you have 102z is equal to negative 204 divided by 102 divided by 102. So our z is equal to negative 2. That is our z. That is our z. So we are going backwards from here. We can determine, we can use n of this. So taking this equation, negative 8, y minus 7, z is equal to negative 2. I'm taking this, but you can also take this other way. You can choose n of the two. We want to obtain our y because we can substitute z in the above. So I'll have negative 8y minus 7 times negative 2 equal to negative 2. This is minus 8y plus 14. It is equal to minus 2, which is minus 8y is equal to minus 16, because we have moved this side and it has become a negative. Here, a negative was a negative, which is a positive. So we have minus 8y is equal to minus 16 divided by minus 8 divided by minus 8. So our y is equal to 2. Our y is equal to 2. So we now have x. No, we have y and z. Can we determine our x? Our x, you pick from previous, the initial one. You can choose any of those and you substitute in them the values of y and z. The first value that you eliminated. So if we choose 3x minus y plus z is equal to 5, substituting y and z in 3x minus y plus z equals 5. You can choose any of the first three to substitute in this. So remember, y is equal to 2 and z is equal to negative 2. So I have 3x minus y, which is a 2, plus z, which is a negative 2, equal to 5. So I have 3x minus 4 equal to 5. 3x is equal to 5 plus 4. 3x is equal to 9. Divided by 3, divided by 3. Our x is equal to 3. X is equal to 3. Hence, x is equal to 3, y is equal to 2, and z is negative. That is how we solve those equations, a system of equations. That is how we would have to solve a system of equations. Question 1 in our reader 107 had that first part A and part B. So in your free time, you're going to try out part B. Let's look at question 2. Even question 2, we are not going to do entirely, but let's first see how we are supposed to come up with the answers. Question 2. This is the reader. Page 107. It says, now, before we actually do this, here, when we are studying, we are learning the concept. How do we solve a system of equations? In the exam, you're going to be required to read a passage and formulate these equations. And in our revision, we are going to see those questions, how they are set. You'll be given equations which you're supposed to read and then formulate the equations and solve. So you must read the passage, pick out and formulate the equations, and then go ahead and solve them. So you must know the relationship. Read the question and understand the relationship, and then come up with the equation. You must know that what has been set is actually linear algebra and calculus. So one of them is this question 2. It can be set that way, the way you see it there. It says, a company manufactures 3 products, X, Y, and Z. A company manufactures 3 products, X, Y, and Z, each of which must go through 3 processes, A, B, and C, for the following items. A company manufactures 3 products, X, Y, and Z, each of which must go through 3 processes, A, B, and C, for the following items. We have X, Y, and Z, and then the time spent in a process. The time spent in a process. The maximum capacities of processes A, B, and C are 130, 85, and 60 respectively. Calculate the number of units to be produced by X, Y, and Z. By X, Y, and Z. To ensure utilization of maximum. Utilization is maximum. So the question is like that. Now the person who has done linear programming, you would be asking, why you don't consider that as a linear programming? In this case, you realize that you have no objective. You have not been given any objective, and therefore you cannot take this to be You don't have the contribution in terms of profits. Therefore, you can't take it to be linear programming. Rather, it should be linear algebra. So they are saying that a company manufactures 3 products, X, Y, and Z. And these X, Y, and Z must go through processes A, B, and C. So the maximum capacity of a process has been given. And therefore, we are supposed to determine our value of X, Y, and Z. So let's formulate the equation. Formulating the equations. Who can help us formulate the first equation? Who has seen the first equation?
3x plus 3y plus
3
2z is equal to
3y plus 2z is equal to
130.
130. That is the first equation. The second equation is, this is process A. Process B, which is
3x
3 plus
2y
2y
is equal to 1
is equal to 1 is equal to 85. And our process Z, it has x
plus 3y
plus z
z
is equal to
60.
Then we go through the same process to ensure that we actually get our x, y, and z. Now, when you look at these equations, the 3 equations, ideally these are very easy because you can see in process B, we don't have z. So simply pick A and z to eliminate z, such that you have x and y. In this case, it is very easy because process B only has 2 different variables. So you do not need to actually go ahead and determine. There is no need for you to go ahead and select two equations. Here you just need to select once, because here we do not have z. We actually have 0 z. We have 0 z. So where we have a 0 z, whether we include it there or not, it is okay. So in this case, what I'm going to do is to ensure that I select 1 and 3 to eliminate z. Thereafter, I will use the two equations to solve for x, y, and z. Is there anyone who cannot solve this? Be open.
We can solve it.
Yes. Those who cannot, please make sure that you find a way of solving. But I know all of us can solve these equations. We are going to look at many more others in our revision. And we shall see in the revision majorly, we want to understand how do we identify that this is linear algebra, because we shall be looking at the questions. There are questions which are linear algebra, but they are similar to linear programming. So how would you know that this is linear algebra and not a linear programming? And then we shall go ahead and solve that. So come Sunday, on Sunday, you're supposed to have a class which is going to be physical. We shall have to look at a number of them. We shall have to look at a number of them. So the next thing is a quadratic Do we still have some time to enable us finish this? I see we have 10 minutes. I guess we don't have enough time. But solving quadratic equations, again, we have a number of different methods which we are supposed to use. That is, we can use the formula, we can use factorization, we can use completing squares, and we can also use graphical method. But it looks like we don't have enough time. And so I guess we can end at that.
Thank
And
you. Thank you, lecturer.
on Friday as we meet, we shall start from there.
Excuse me, sir.
Yes, you are.
In the above question, examples in part B, how do you use those ratios?
In the above questions, examples in part B.
Yes.
Mm.
I'm inquiring, how do you use those ratios?
We are supposed to determine an equation from there. It is y to z equal to 2 to 1.
2 to 1. Yeah.
When you have y to z, this is the same as y over z, which is equal to 2 over 1. Then we cross multiply to have 2z equal to y. That is an equation.
Okay, thank you.
Then you go ahead to determine the values because the others are very open.
Thank you.
You're welcome. Any other question? Okay, since we have no other questions, we can end our class at that. And let's meet tomorrow at 1:45. 1:45. Thank you very much for attending today's class. Have a nice evening.
Thank you.
Thank you too.
Bye.
Bye.
Okay.